turn off this microphone and use this one. Just so. This one works? Yeah? Fine. Okay, I have no idea what the field of view is for the video camera. So, thank you all for being here. Number one, the theme of what I want to say at the end is all about people. And it's such a joy. If I don't know when I'll next have an opportunity to take a sabbatical, but for me, the best sabbatical would be to spend a week with each of you, just catching up on everything. Well, that won't happen for a while, but at least today we have a compressed time where I can spend a day with all of you. So thank you for coming. Really, what I always enjoy is, and I really appreciate many of you also reflecting that, connecting with people in my new role as Dean. These are my 5 colleagues who are school chairs that I work with very closely. And we think of our mascot Buzz as a person too. Akihiro introduced him as well. Okay, so just, I think some of you are aware of this, but just some background. I had this experience of living in going to a very unique boarding school in India, which is up in a fort. And that created, again, this very big sense of community, because all of us boarders were pretty much there morning, evening, night, weekends, except for when we'd go home for vacations. So I still have a very active WhatsApp group. And yes, question. Sarkar University. It could be. It's an old fort, and within the fort there are like temples that date back to 800 AD, and then it was used as a British fort. When we would roam around the grounds, you would come across old British cannons all over and things like that. It's a pretty unique place. We're actually gearing up for, it's not too many years away for our 50th reunion. So yeah, we have a group where everyone says, okay, everyone keep your limbs moving so you can make it to that. Then, as I mentioned earlier, I was fortunate to go to IIT Kanpur. That's where Ganesh was my TA. A number of people we overlapped with. I'll just mention some random names as I can think of them. Some of you may know Jitendra Malik, a big leader in AI. So he overlapped with me. Arvind Krishna, if you know his name, happens to be CEO of IBM. We overlapped over there, and a number of other people. Another person, very importantly, whom I overlapped with, and Ganesh alluded to this, is my wife, Ratna. And there's our photo working on a VT100 deck terminal, which was, by the way, an upgrade from punch cards. My first programming class was on punch cards. So this was the new computer center, deck 10 with these VT100s. And then, of course, there I was really lucky in terms of like check off one big item on my to-do list. so we are fortunate. I should have included a family photo, but since Raja was mentioned, I included a photo with our dog, who was very much part of our family photo. This was taken many years later at Rice University. And Prasant mentioned my undergraduate advisor, Keshav Nori, who was a big influence. He actually spent a couple of years working with Niklaus Wirtz in ETH. And this was, of course, before the web and all. So he came back to IIT Kanpur with a bunch of magnetic tapes with all the source codes to the Pascal and the modular compilers. And he'd give us programming projects to modify those compilers, which was really unique. There was nobody had access to anything like that. And also, speaking of, Prasant mentioned BTech project, credit goes to my wife Ratna, because she and I were partners on that BTech project. It was very unusual for a software project to get that prize, because it was actually an electrical engineering project prize. Okay, now mentors. I was so fortunate to have John Hennessy as my PhD mentor. This is, of course, before he became department chair, dean, provost, president, and he is now chairman of Alphabet. He doesn't know how to retire, but I tried to capture some lessons that I learned from him. And actually, he was very open as an advisor. There were best practices, and later you could also, I learned something that's serving me well in my role as department chair and now dean, also open discussion on interdepartmental politics. So we would chat about research, but we'd chat about the academic environment. So a few things. Can anyone guess what was John Hennessy's PhD dissertation on? Which area of computer science? Computer architecture is a good guess. I think that's what most large language models would guess. So there. Compilers, yes. And not only compilers, a topic that still needs a lot of advance, which was debugging of optimized code. That was his PhD dissertation. And he came to Stanford and started the whole U-code compiler system. Fred Chow, one of his major students, and that ended up being the compiler for the MIPS company, and then later on Silicon Graphics and so on. So that's how I ended up working with him. But at the same time, the reason he got into RISC architecture is because the principle behind RISC was you need compiler support for RISC architectures. And of course, you know, he and Patterson and, you know, their collaboration took off in so many ways. But back then, Hennessy was in electrical engineering, not in computer science. And that had a separate dean, because computer science back then at Stanford was in arts and sciences, not engineering. So he would chat with me quite frankly about all the politics that would go on. That's that last bullet. And I learned a lot from that. But at the same time, he said, hey, we need to form a place. So we have this thing called Computer Systems Lab, where faculty from E and CS can be co-located students. And in that lab, we really didn't know which faculty member had which department as their primary appointment, and even which PhD student for that matter. So learned a lot there. Oh yeah, there was some mention about my PhD thesis. So the thing I enjoyed was just trying to figure out this thing, execution time as a function of granularity. If you're really fine-grained, you can have small execution time, but when you get ideal execution time, but lots of overhead. So intermediate point, and this was a system I worked on, which is how do you figure out cost? You don't know, you profile it. Later on, whole profile-driven optimization became a thing, and all of that. So this was fun to work on, and this was all driven by these cost functions that people were talking about. But one of the things that I really appreciated was working with this team led by Livermore, but with partners everywhere with, where's Louis Noel? Yes, over there. Colorado State, actually, Rod Olderhoft, when he was there, and there was a PhD student, I'll mention him over, David Kahn. So this is a language. It had Pascalish syntax, but it was a pure declarative language. So this was like quicksort, you know, saying you kind of split the input data array, and then you recursively call quicksort. And this is a data parallel for loop. You know, there was abundant parallelism over here. You didn't really need to do dependence analysis to find the parallelism. The language was declarative. It was the parallelism. And so you could build these graph representations, and essentially all my partitioning and scheduling work was on these graphs. And initially, I could only work, like those papers only had results on simulators, but we were so grateful to get access to like a 12 processor. I think this was sequent processor, multiprocessor that David Kahn was the person I was thinking about. We had this paper about the impact of parallelism and all. Not to get too much into the weeds, but some of the things in Sisal, that was parallel code. You could write sequential while loops, but in a declarative functional way. Now, most of my functional programming colleagues would much rather write tail recursive functions, but if you're talking to scientific programmers and all, so what it is there's a difference between the old value of a variable and the new value of a variable in the loop body. And in retrospect, it's like there's an implicit phi function in the header where the back edge is carrying the old value and feeding into the, but because these two are distinct, you never have to worry about any storage-related dependencies. Everything was a true dependence. And you could refer to the new I or the old I anywhere, and you'd still have the dependence graph. So I thought this was pretty cool. And this is a way to trick imperative programmers into writing functional code, frankly. And yeah, I just got this. I'm truncated over there, but this is from our commencement ceremony. Somebody else who graduated at the same time, who's really well known in the community, is Anant Agarwal. And then between us is Peter Steenkist. So Anant, of course, went to architecture. Peter is a leader in networking at CMU. So lots of good memories from there. And then, of course, as I mentioned earlier, and Mike really helped me out by giving a great summary of the IBM years. It was such an honor to have Fran as a mentor for all of us. And I'm trying to think of all the lessons I learned from her. I don't think it's complete. But certainly these values which she completely exemplified: integrity, trust, equity. I have okay, yeah, I have time, why not? There was PLDI, when was it in Toronto? 91, I think. Yeah, does that ring a bell? So she was actually, I think, sick plan chair, if I'm not mistaken, or certainly on the sick plan EC. And I see her, I think I had a paper there, no, yeah, 91. And I see her in the evening, just after the session, before the banquet, her face is red. It was a complete giveaway because she was so fair. If she was bugged about something, you'd see it on her face. So I said, "What happened, Fran?" She said, "You won't believe what they did." She said, "Come." And she takes me to the banquet room. The banquet dinner was about to start in an hour. She said they put the reserved table for the EC on a little bit of an elevated stage. It was like 6 inches higher. You know, some hotels like to do that. Not to, frankly, I've seen that more in IEEE meetings, just saying, but we normally, we don't have that culture in ACM. And she was just, she said, "No way we're going to sit in an elevated thing." So she had the hotel dismantle that whole platform and all of that. So that's equity, and lots of other volunteer leadership for sure. Because Mike did such a great job talking about the P-Tran days and all, and also partly because those are the days we were not carrying cameras. In fact, Fran was the most avid photographer. So unfortunately, it's all lost at some point. But somewhere, I remember the photos she took when she became an IBM fellow. We had a get-together at Gene and Larry's home, and she was going around taking tons of photographs of everyone. Unfortunately, I don't have those. But I have the memories, which is great. This was a chapter in my career which had a profound influence on me. I like doing non-traditional things or contrarian things. So when you're on a path of research career, I had this opportunity, and Mike alluded to it, to move to Santa Teresa Lab, Silicon Valley Lab as it's called, to actually leave research and join a product group. And some of my research colleagues were saying, "Wait, you don't know if you'll be able to come back to research again, don't do that," and so on. And, but Fran was the one who encouraged me to do it because, as Mike alluded, this was an opportunity for us to do technology transfer from the P-Tran project into this product that we called ASTI, and that was an acronym. Scalarizer is the business about converting like slice notation in Python or array notation in Fortran into scalar code. So this is the team that I was part of. It was, I mean, you can see me blurred out there. Morgan Young was the manager. What really struck me is many of these people I remember, and I think, Mike, you might remember interacting with some of them, John Ng, Ray Ellisek, Jin Fan Shaw, Michael Lai, Kwan Yun, such brilliant compiler experts, but working in industry. And actually, you know, I felt they were solving harder problems than what I was seeing published in PLDI, but they were working in different time increments and just in different modalities. So we built a system called ASTI. It was completed in 93. There was an internal thing where it got and IBMers know all these details, transferred to Toronto, but it's been shipping since 96. And about 3 or 4 years ago, I visited Toronto and met someone who was still maintaining that code. So, and it's been shipping in the Fortran compilers ever since. So it actually was, people use the term middle end quite often now. It was IBM's first production middle end optimizer. So not at this AST level, not at the low level, like this is equivalent to like an MLIR type optimizer back then. So that was a lot of fun. And one of the things back then, compile time was a big deal. So all these parallelizing compilers, their big challenge was, first they run dependence analysis that could take minutes or even hours for large code, and then the programmers would give up, and then may not have benefits. So we had an architecture where we would say, first use cost to figure out what code you want to generate, what transformation, then do the dependence analysis to see whether a transformation is possible. The big difference there is if somebody wrote well-tuned code, you figured out that you don't need to change the code, so then you don't need to do the dependence analysis. So right away, the compile time became better for well-tuned code and so on. So that was a lot of fun. Let me switch gears. Then after that, I was kind of at a crossroads whether to get back into research or not. And IBM gave me this opportunity, it also combined with some personal constraints, to take this visiting position at MIT, where, by the way, I also taught, Manu's still here? Yeah, he is. I taught 6035, but that was before your time, because I taught in fall of 96 and fall 97. Yeah. So, which was the compiler class with 80 students and all of that. But one of the things over there was my meeting Kat Nope. So backdrop over there was, during this period, as Mike alluded earlier, my good friends, Ron Citron, Gene Ferrante, Mark Wegman, Kenny Zadek, and others had developed static single assignment form. It was great to be there when all that was developing. But when Kat and I started talking, we said, well, for code transformation, there were some limitations. One is, you call it a phi function, that's fine for program analysis, but it does not have operational semantics. Just the phi by itself doesn't tell you, do you pick x1 or x3? It's fine for program analysis because you know you'll get one or the other, but if you were to actually execute it. So in that sense, it's not a pure function. And another issue is, which is what we got into, is like, if you want to do aggregate data structures like array, and you say you're assigning one element of an array and you want to rename it to A1, now you're accessing A of j, should you be referring to A1 or A0? Well, it depends on whether j equals I or not. If j is the same as I, you get the new value from A1, otherwise you get it from A0. And a scalar SSA doesn't help you with that, because it's scalar, it assumes that the whole variable is overwritten. So this idea of preserving definitions also didn't work. By the way, there have been lots of advances since then. My good friend Fabrizio finally came out with this SSA book that some of you may be familiar with, and we have one chapter there on array SSA form. So there's Kat, as was mentioned earlier. So she was just finishing a PhD. She had also taken a non-traditional route, working for Compass, I believe, which was a compiler consulting company, then going back to grad school. She did a PhD under Bill Daly. And she was in a final year when I came to MIT. So we ended up meeting at least twice a week or so, just bouncing ideas. And so this whole, I remember several whiteboard discussions about what to do about this issue. And we said, okay, if we want to give it an executable semantics, we could think in terms of these timestamps that say when so this is just a scalar, when a value was assigned. So now if you need to choose between some values S1 and S2, you look at the timestamp and you say if S2 was assigned more recently than S1, then pick S2 else S1. So now the phi function has an operational semantics. And then and this was part of work that paper that we had way back in Popple 98. And then, but then what about the array thing is that we have to figure out, are you getting the value from one array or another when you assign an element? And that was what we said, well, first you need a merge of the two because you can get it from others, and this is straight line code. So it's not a standard SSA phi, so we call it a definition phi. And so then we figured out that this timestamp business can also be extended to arrays, and now you can figure out which element you get, whether you get it from one definition, like if it's K, or the other one. Okay, so that was, I mean, it was, and then later on, of course, and I won't have time to say much about that because Louis Noel did a great job talking about all the CNC work, but the partnership with Kat has been amazing. There were other collaborations at MIT, of course. I worked quite closely with Anant Agarwal's group on the raw multiprocessor project. And I worked with this PhD student, Max Poletto, on linear scan register allocation. So there were lots of other things going on there. So sabbaticals can be great when you get them. Okay, so Mike already showed this picture. It was awesome to have the JIKES RVM team to work with. And then one of the results we had there, we started the project sort of in November, December 97. Certainly we got going by Jan 98. And this was IBM JDK, the production system, on one of IBM's servers. And as you were trying to, what was this called? Spec JBB, right? I think that, PBOB, or I think it was also called JBB. I don't know, I can't. PBOB, yeah, Spec JBB. When it became Spec, it became Spec JBB. And the idea was that the production JVM, which IBM was licensing for front, just wouldn't scale, and that was key for IBM So our own virtual machine for Java, written in Java, scaled much better, which really surprised a number of people. Some other nostalgic memories Mike mentioned. I found this just now, and I have no idea why this is highlighted. That's not significant. But formatting aside, hopefully it's bringing back memories, at least for Mike and Frank. This was an org chart. I was so lucky to have 6 groups. I mean, they're all legends in our field: Vasbala, Evelyn, John Field, Mike, Mukund, Frank. They were all the managers, and then all the various people in their group. You could see Satish Chandra was there, and both Iran was there. Later on, Marta Vechev was there. It was an awesome time. And then when we started X10, Vijay was reporting directly to me, since he was really he and I were working so closely. This was in one of our offsite meetings. And that same offsite meeting, my eyes are closed, but we had this Project Pride where we had these little stickers for each of the projects. And there was a logic. I tried to, okay, now I might need your help. But it was, this row was programming models. There's X10, XJ, I forget. I think this was maybe, yeah, and then program analysis. There was Azure, Domo, Safe, Iran stuff. You guys will remember more. And then there must have been Metronome or something. Is that Metronome maybe? I'm not sure. Yeah. Yeah. Well, so each of them represented a project that people were passionate about and working on, and many of them led to many great papers. So Domo became what? Yeah. And there was a brief instant when Steve wanted to call it Detox for some reason. It was actually called Detox Repository and then got renamed to Wala, right? Yeah. So lots of good memories. Then I went to Rice. That was a big decision. Zoran mentioned Ken. He was a big figure in our life. He had begun talking to me in 2005 about considering academia. And then he said, come for a visit. Later on, I discovered it was an interview visit. So I went in April 2006. Meanwhile, we had, Zoran and I had already been collaborating. And Mac, whom you can see over here, Mac, where are you? So yeah, there. And Raj is there, and there's Raghavan. So I just arrived soon, and this is just showing how collegial the department was, that, us folks working in the PL compiler area, but I was also fortunate that Zoran, Mac, and I had already begun collaborating. Mac was in an IBM fellowship at that time. So it became natural for me to take over as Mac's advisor after I came. And there was a community as soon as I reached, which was awesome. Raj and I had been working at IBM, so he was already there as, joined me. There's Waleed Taha, by the way, and then Mac, and then Raghavan had independently started at Rice, but then moved to my group. And Zoran. So having that core was really helpful for me when moving from IBM. Otherwise, all of you in academia know if you move to a new place and just start from scratch, there's a ramp-up period. So this was really great. And here's some more photos from that time. You could see my dog figures there too, Raja. In fact, there was a bed for him in my office. And I remember, Prasant, you telling me that you were very scared of dogs when you first, but then you got used to him, right? Yeah. And here's one. We do so much runtime research on load balancing, but I totally failed in this case because there were 5 PhDs who graduated in the same year. So it was not a good job of load balancing. But you can see there's Dragos, Alina, Sanak, Deepak, and Shams. And then you can see other people in the group. There's Max, there's Tiago. Who else is here that I should be? Of course, June, Jisheng. I think Akihiro was, there's Akihiro, right? Yeah. So it was and Kat was working so closely with us with CNC. On CNC, she would visit us many times. So you can see she's in the there she is. Yeah. And because some of this, especially Alina and Dragos, their PhD was really driven by CNC in many ways. So it was great for her to be there too. Okay, and then part of the welcome was, Sadeh alluded to this, we had large projects. Keith was PI of this DARPA project called PACE. So it was great to have Sadeh as a collaborator over there too. And there was this company, ETI. I just realized I haven't had any slides with Gao. My connection with him goes back as long too. And but that was one connection. Though he and I started collaborating way back when he was in McGill. Um, then this is a slide that Jason showed. This was a great partnership. And actually it shows that those of us who work on programming languages, compilers, if you can connect with colleagues who work in an application domain, it uh, brings so much vitality to your research. And there were some of my PhD students who actually said that even if they didn't do anything directly in that domain, it was just so inspiring. In this case, Denny Aberley is a radiologist, an MD. She showed us exactly how she has to read CT scans and other MRIs and all to give various assessments to the physician. Then it sort of really motivated you in terms of, and the main thing we were doing over there was trying to do many of these analyses much more, like a few over an order of magnitude faster than the state of the art. And then Jason's team led this very unique test bed in 2010-11 that had FPGA and GPU and multi-core CPU, which we used a lot. Now what happened? Did I mute something? No. Okay. Then I ended up moving to Georgia Tech in 2017. There again, I benefited a lot that multiple members of the group from Rice moved, particularly June and Akihiro and Jisheng. And here's a photo taken with some other colleagues. Some of you may know Santosh Pandey, Alex also. And then the photo on the left just, or your right, sorry, reminds you of, what things were like in the pandemic. And when we felt it was safe to meet outdoors, we would just meet outdoors. I'd bring a bag of cookies. We'd at least be able to spend some time with each other instead of only virtual meetings. Oh, that is another Georgia Tech mascot. It's called the Rambling Wreck, and it's a big treat to ride in it. So yeah. It comes out in football games and all of that. Yeah. There are a few replicas. So if you guys come to campus, we'll find, we do get it for student events and things like that. Okay, so I'd like to start wrapping up now. So when I look at where we are right now in our lab at Georgia Tech, really fortunate to have Akihiro, June, and Jisheng, who've been so long. June mentioned he started my group in 2008, so 16 years. Akihiro, 12 or 13, something like that. So it's been nearly a dozen years. Jisheng was around the same time as June. We have, I have other responsibilities, but the way the research agenda continues in my group is really thanks to them. And then here are the PhD students. Some are here, at least Yusuf and Zitong are here. I think anyone else? I think at least the two of you I know are here. And I hope I'm not left anyone out. So just for fun, I went to the ACM Digital Library to see, if you want to explain what do we do in our lab, let's see what the ACM Digital Library says based on publications. So they have some keywords which are not off, parallel programming, actor model and things, and subject areas, but it doesn't give you the full picture, but it gives an idea. So one way, we think we work on pretty much one thing, but clearly we work on a number of things as far as the rest of the world is concerned. I think we work on multiple aspects of related to parallel software, which span programming models, compilers, runtime systems, and debugging. And here are some of the questions that we want to answer in each of these areas. And what kind of unifies this is this, which is what Zoran was referring to with async, finish, futures. We have a consistent set of primitives. So even if somebody is working on programming model and runtime and compiler, they all know the same semantics. Like somebody is optimizing a finish operation, someone's implementing it in runtime. You heard Akihiro refer to it in the actors thing and so on. So that's how, and then if you're doing debugging and verification, it's for the same primitives. One Venn diagram that has actually lasted a long time, I think Vincent was the one who first created, was this idea that if you use different primitives, you get different guarantees. So for example, If you only use the async and finish constructs, then you're guaranteed to have a deadlock freedom, which is a result that actually Jensen, a student, proved in his X10 featherweight X10 paper, and also this other property that data race freedom implies determinism, and as you add more general constructs, you get fewer and fewer guarantees. So that's a trade-off, and it's not a surprise. I mean, you can do everything with threads and locks, but you have no semantic guarantees. So this gave us like a compass as to how to constrain things and to get guarantees automatically for all programs in that subset. Okay, I want to wrap up just by acknowledging all the PhD students in the group. Since I moved to academia, I did have the opportunity to advise or co-advise a couple of PhD students before them, most notably Igor Peshansky. I remember when I was at IBM. But I go to academia in 2007. My first PhD student graduates in 2008. How does that happen? Well, it's Mac, because we were well along the way, and I was engaged in his research along with Zoran and Ken and all of that. And this was very much related to X10. Same with Raj. Raj and I had already been working on register allocation and other topics. So he was at that time both at IBM and then doing a PhD in ETH Zurich with my good friend Thomas Gross. And I had that discussion, they'd like to move to Rice, so that worked out. Then Yigo, who was already a PhD student there working with someone else, transferred to my group, so he graduated in 2010. Raghavan, as I mentioned, had joined Rice in 2007, but then joined my group. So this kind of helped our group get off the ground right from the start, which was really, really great. And it goes back to the collegiality that there was in the department. So here's Sanjay. Where's Sanjay? There he is, right? He got his PhD in 2013. So these are all people we, of course, know well and try to get together in virtual meetings. And then there were a total of 16 in about the 10 years at Rice. The last couple actually moved with me to Georgia Tech, but remained Rice students. And that's also something that shows how academic units can collaborate with each other. They were getting paid by Rice while they were sitting at Georgia Tech, but they had full access to Georgia Tech, ID cards and all of that. Tiago had a similar experience, I think, and so did others. And then in Georgia Tech, since then, we've had 9 more, so we had 25 graduates. So this has been really great. Okay, so I think good time to wrap up. It's been a long, long day. As I said, what have I learned over the years? It's all about the people you work with. And I hope I've had the pleasure to be connected to many of you one-on-one. I hope you've been able to connect with each other a bit today, and we're going to have this reception to also connect some more. Here's a photo. Actually, I want to replace it by that other photo, but I didn't get it in time that we took. But the future version of the talk will have a VivekFest photo over here. This was one when I became a dean at Georgia Tech. They had a reception. And, you know, there's such great colleagues there. There's some people who've been at Georgia Tech for 35 years, approaching 40 years, and very dedicated to teaching and research and all. So I'm glad to be in this community. But I would just like to end by thanking all of you for all the great time that we've spent together. And thank you for being here. So, and look forward to more discussion. Thank you. Wow, wow, wow. Thank you. It really blows me away to see all of you whom I respect so much. So let's enjoy the day, and we have a reception just around the corner in San Diego room. And of course, special thanks to Raj, Jens, and Rajiv for the organization. Right, this was a great event. So thank you, guys.